So let's come to the next question, the last part of this question. The last question is 11th part. What is the question? The question is fx is x to the power 4 upon 4 minus 2x cube plus 11x square upon 2 minus 6x. Now you have to again determine the intervals in which the function is strictly increasing or decreasing. So first step is find the derivative of this function. So it comes out to be 1 by 4 into 4x cube minus 6x square plus 11 by 2 into 2x minus 6. Right? So 4 goes away and this 2 also gets cancelled. This is x cube minus 6x square plus 11x minus 6. Again you got a cubic polynomial. So that means first step is to find the first factor using hit and trial. Put the value of x as 1. I think it is similar to the question that we have already done because you got minus 6 and minus 6 again minus 12 and this will be plus 12. So that means one of the factors is x minus 1. How do you find the other factor? I'll just repeat it even though we have done it, but still write the coefficients of all the terms of the polynomial like this and make two lines like this. X minus 1, so that's why you'll write a 1 here. First term will come down as it is, 1 into 1 becomes 1. Minus 6 and plus 1 is minus 5, then 1 into minus 5 is minus 5, 11 and minus 5 becomes 6. Then 1 into 6 is 6 and minus 6 and 6 becomes 0. So last term has to be 0. If you don't get 0 here, that means you have done some error here. So now let's write all the terms with 1 degree lesser. So this becomes x square and then minus 5x and then plus 6. So that means the other factor of this polynomial is x square minus 5x plus 6. Factorize this by splitting the middle term. It is again going to be minus 2 and minus 3. So the three factors are x minus 1, x minus 2 and x minus 3. Again the critical points are x equals 1, x equals 2 and x equals 3. So you can write all the three critical points on the number line 1, 2 and 3 because it is all positive, all the coefficients are positive. So last interval will be positive, negative, positive, negative. So that means this function is strictly increasing in what intervals? It is strictly increasing in, write the positive intervals. Minus 1 to 2 and union 3 till infinity. And it is strictly decreasing in which interval? Minus infinity till 1, union 2 to 3. So done with the last question of this question 13. Question 14. Find the interval in which the function fx is equal to x square e raised to the minus x is increasing. So this is question number 14. Fx equals x square into e raised to power minus x. Now again, how will you differentiate? First find the derivative. First function is always to differentiate first function into derivative of the second function. E raised to power minus x into minus 1 plus second function as it is into derivative of first function. What can you take out common? What is common now?
E minus x.
E raised to power minus x is common and x is also common. So x is also common. What is left out in the first block? Minus x. And what is left out here? Plus 2. So it has been factorized now. Right? So what are the critical points? This is going to give you x equals 0. If you equate e raised to power minus x equal to 0, there is no value of x that is going to suffice this condition. So that means this does not exist. This does not give you any root. So you can ignore this factor. X gives you x equals 0. What about this? Minus x plus 2 equals 0. That means what is the value of x? X gives you 2. So you got two values of x, 0 and 2. Now let's plot them on the number line. So it is 0 and 2. This is minus infinity and this is plus infinity. Now because if you look at the coefficients of x, only look at the coefficients of x. One is positive, one is negative. That means overall is minus. So the rightmost interval will be minus, plus, minus. Now as for this number line, let's write when the function is strictly increasing. When is it increasing? Only in this interval from 0 to 2. And when is the function strictly decreasing? Minus infinity till 0, union 2 till infinity. So the question was, it was asking you only about in which interval it is increasing. So you just need to write this one. In case decreasing is also asked, then you will write this also. Right? Now question number 15. Fx equals x square e raised to power x. So this is similar to the previous question. The only difference is exponent here is positive. Exponent has a positive degree now. It is plus x and in the previous it was minus x. So how do you differentiate? What is the derivative of this function? First function into derivative of second function plus second function into derivative of second function. Sorry, first one. Now what is common? E raised to power x into x. So what is left out? X plus 2. So these are the factors of the given expression. So for e raised to power x, there is no value. It does not exist. The value of x does not exist. So you can ignore this factor. What about the next factor? It gives you x equals 0. What about this? It gives you x equals minus 2. So now plot them on the number line. It is minus 2 and 0 plus infinity and this is minus infinity, right? The question says find the intervals in which the function is strictly increasing or decreasing. So you have to write both in this case. In the previous it was only increasing. Now you have to write both the intervals where it is strictly increasing and decreasing. Now look at the coefficients of x. They were all positive. That means the rightmost interval is positive, negative and then positive. So it is strictly increasing in what all intervals? Minus infinity till minus 2, union 0 till infinity. And it is strictly decreasing in which interval? Minus 2 to 0. Okay? Clear? Okay. Now the last question of this exercise. Question number 16. So I'll just write the function fx equals 2 log of x minus 2 minus x square plus 4x minus 5. Now don't be scared if there is a word log here. It's fine. So let's first find the derivative of this. 2 is a constant. So as it is, log derivative of log is 1 upon x minus 2 into derivative of x minus 2 is 1 minus 2x plus 4. So this is the derivative. You can write it as 2 upon x minus 2 minus 2x plus 4. Now you take the LCM and then we'll try to make the denominator a perfect square. So let's first take the LCM. If you take the LCM, numerator will be what? Minus 2x into x minus 2 plus 4 into x minus 2. Just simplify this and see what you get. 2 minus 4x square plus 4x plus 4x minus 8 upon x minus 2. So this is minus 4x square plus 8x and then minus 6 upon x minus 2. It should be 2x square here, not 4. So this is 2, this is 2. Because when you multiply this and this, it becomes 2x square. So it is minus 2x square plus 8x minus 6 upon x minus 2, right? Now you need to convert this denominator into a perfect square so that you don't have to bother about it. Before that, let's factorize the numerator. In the numerator, can you see any common factor? Minus 2. So you take minus 2 out. What is left out is x squared plus 4x minus 3. So it is easy to factorize this now. What are the factors of this? 3 ones are 3. So how do you factorize? It is, I think there is some problem with the sign.
Minus.
It should be, yes, it should be minus 4 here. It should be
Plus
minus 4, and it should be
plus 4x here. Minus 2x in minus 2x in x.
plus 4x, and this is also plus 4x, which is plus 8x. पर हमने कहीं पे एक minus 2 कॉमन लिया ना यहाँ पे. Okay, factorize the numerator. Minus 3 ones are 3, minus, there's something wrong with the sign. Okay, you have taken out minus 2 here. So it is going to be minus 4x and plus 3 because we have taken out minus 2. Minus sign is already out. So that's why it is now factorized. Now you can factorize. It is minus 2 and in the brackets you will have 3 ones are 3. So minus 3 and minus 1 are the factors. X minus 3 and x minus 1 whole upon x minus 2. Now, if you can make this denominator a perfect square, then you don't have to bother about its side. So how do you do that? It will be minus 2 into x minus 1 is already there, x minus 3 is already there, you bring x minus 2 also and make the denominator as a perfect square. Now you just ignore the denominator, that even if, as if it is not even existing. So what are the critical points? What do you get? What are the critical points now? X equals 1, x equals 2 and x equals 3. So now plot them on the number line 1, 2, 3 plus infinity and minus infinity. Now because there is a minus sign here before this expression. So what is the value of this expression? X, if x is positive, plus a minus. So that means rightmost interval will be minus, then you have plus, then minus, and then you have plus. Right? But because you had one of these factors in the denominator, that means x cannot be equal to 2. X cannot be equal to 2, right? So that means this function is now strictly increasing in which interval? Okay, one thing we missed out here was the question had a log expression. There was something called log of x minus 2, right? Let's look at that once more. So let's relook into that. So it is log of x minus 2. Now log never exists for negative numbers. That means x minus 2 will be positive. That means x will be greater than 2. So for this question, x has to be greater than 2. So that's why when you are writing the intervals for strictly increasing and decreasing, you will consider only the intervals on the right side of 2, not the intervals on the left side. Just ignore them. So the answer for this is going to be strictly increasing in the interval 2, 3 and decreasing in the interval 3 till infinity. Now here, why the interval starting with 2 is open? Because x cannot be equal to 2. We have written this condition also. So it has to be a circular bracket, not a square bracket here. So this exercise is done, and after this we are going to start a new topic, maxima and